Day 543 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3,354, make array elements equal to 0. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums by selecting a starting position cur such that nums cur is equal to 0 and choose a movement direction of either left or right. After that, you repeat the following process. If cur is out of the range of 0 to n minus 1, the process ends. If nums of cur is equal to 0, move in the current direction by incrementing cur if you are moving right or decrementing cur if you are moving left. If nums of cur is greater than 0, decrement nums of cur by 1. Reverse your movement direction. Left becomes right and vice versa. Take a step in your new direction. It says a selection of initial position cur and movement direction is considered valid if every element in nums becomes 0 by the end of the process. Return the number of valid selections. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input nums equals an array of integers 1, 0, 2, 0, 3, output is 2. So what we want to do is find out how many possible valid selections we can choose from any one of these elements in the array, where when we follow these requirements right here, then after following all these requirements, this whole array will equal 0. So let's look at the explanation so we can see how they did that. So it says the only possible valid selections are as follows. So I'm only going to go through one of these because the same principle applies to both of them, just so we can understand what the question is asking before we get into the solution. But if you understand this, then you'll understand that. It's pretty simple to understand. So let's just look at it real quick. So first, it says choose cur, which equals 3, and movement direction to the left. So when it says cur equal 3, that means index 3. So we're going to come down to index 3, which is 1, 2, 3. Oh, excuse me, 0. We're starting from 0. So 0, 1, 2, 3. Boom. So we're starting at this 0 right here. Then it says and movement direction to the left. So we're going to start by moving to the left. So you see this underscore under the 0, and then you see this underscore under the 2. This underscore lets us know what element we're looking at. So we move to the left. It says right here, it says if nums of cur is greater than 0, we're going to decrement it by 1 and reverse the movement direction and take a step in the new direction. So right now we're at 0. We're moving to the left. Once we go to the left, let's look at this. Now we're at 2, right? Once we're at 2, nums of cur is now greater than 0. So we need to decrement that 2 by 1 and reverse our movement back to the right and take a step in that direction. So after we decrement this 2 and go back, and reverse, remember we started here, went left. So after we decrement this 2 and reverse the direction and move one direction back, we're going to decrement this 2. This 2 becomes 1. Boom. So now we have a 1. And then the 0, we move back to the right because we reverse direction. So now we're back on this 0. Then it says up here, if nums of cur is equal to 0, move in the current direction by incrementing cur if you're moving right or decrementing cur if you're moving left. So right now we're at this 0. We're going to keep moving right. We're going to increment cur by keep moving right. So basically what's happening is every time we're going to start from 0. Every time we run into a number that is greater than 0, imagine us bouncing off of that number. We're going to, subtracting 1 from that number, bouncing off of it and going back. So now we're at 0 and we're going back to the right. So now we're at 3. So what we're going to do, we're going to subtract 1 from 3, bounce off 3 and go back to the left. So when we do that, we're at 0 right now. Boom, we move to the 3. Boom. We subtract 3 from the 2. and we go back to the left. Boom, because we went from 0 to 3, we're bouncing back. Boom, decrement, taking 1 from 3 and bouncing back. So that's what we did here. We went from 0, took 1 from 3, bounced back. Now we're back at 0. Boom, and we're still going to the left. So now we're still going to the left. We're going to bounce off the 1 again. So now, we're going to decrement the 1 by 1. So we're going to decrement the 1 by 1. That's going to become 0. So as you can see, now this 1 becomes 0. Then we're going to bounce off that 1. And now we're back at 0 going to the right. So now that we're back at 0 going to the right, boom, now we're at 2. So the 2 is greater than 0. So we're going to subtract 1 from this 2 and bounce off of this 2. And now we're going back to the left. So this 2 becomes a 1. We bounced off it. Now we're going to the left. So we're going to the left. That's a 0. That means we keep going to the left until we reach another element greater than 0. So boom, we're still going to the left. Now we're at 0 here. Boom, we're still going to the left. Boom, we reached an element greater than 0. So what are we going to do? We're going to subtract 1 from it and bounce off it, go back to the right. So boom, we bounced off it. Now it's 0, then we went back to the right, and now we're right here with the underscore. So same thing, we're moving to the right, so now we go to this 0, boom, still moving to the right, so now we go to this 0, boom, now we move, still going to the right, boom, now we land at 1. So at 1, what we do, we subtract 1 from 1, that becomes 0, and the process ends. Boom. So that's how it works. We're just going to start from 0. Each time we see a number greater than 0, we're going to bounce off it and go back in the reverse direction. Or not only are we bouncing off it, though, we're going to subtract 1 from it, then bounce off it and go back in the next direction. Then once again, we'll get to this 2, subtract 1 from it, bounce off it, go back to the 3, and so on and so on. Oh, sorry, we started going to the left. We didn't start going to the right. But that's how it works, y'all. We just, every time we see a number greater than 0, we subtract 1, bounce off of it, and go back to the other direction. That's how this works too. So if you still need help understanding, I suggest you go through this on your own until you can make it make sense. And just remember, we start from 0. Each time we're going to pick left or right. Each time we pick one. And each time we land on a number that's greater than 0, we subtract 1 and bounce off it and go back the other direction. So in example 2, we have our input nums equals an array of integers 2, 3, 4, 0, 4, 1, 0. The output is 0. It says there are no possible valid selections. So that means out of all of these numbers right here, we could pick any one of these zeros. It doesn't matter. No matter which way we go, following these requirements up here, we will not be able to turn this whole array into all zeros. So we just return 0. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, the first thing we want to do is we want to compute the prefix sum of the array. We're going to use reductions for that. And reductions just produces an array where each element is the cumulative sum of up to that point. So I'll show y'all an example, but first let's declare this constant. So we're going to say let prefix sums equal nums dot reductions, open up the parentheses and put the plus. So once again, what this reductions does right here is it's going to produce an array where each element is the sum up to that point. So for example, right, say we have an array and it looks like this. Say it's 1, 0, and 2, right? And say after the reduction, it'll become an array 1, 1, and 3, right? Because the sum up to this point right here is 1. Come back here, the sum up to this point between these two numbers is still 1. So we put 1. Then we get right here, the sum up to of these 3 numbers will be 3. So once again, it's the sum of each element up, it's the, it produces an array where each element is the cumulative sum up to that point. So that's what that means. Boom. Then we need the total sum of the array is going to be the last element of the prefix sum. So we could just say let total equal prefix sum dot last and put the exclamation point. Then we need a variable that will hold the number of valid selections that satisfy the conditions or our output. So we need to store our output somewhere, so we can declare a variable called count, and we could just set that equal to 0 just to start. Boom. Now we need to iterate through all indices of nums and only consider indices where the current element is 0, because we're going to start from 0, right? It says start by selecting a position cursor such that nums of curves equal to 0. So we need to find which elements in the array are 0 so we can know where to start looking from. So we can say for I in nums dot indices where nums square bracket I equals 0. Then we can open up the brackets and we can calculate the absolute difference between the total sum and twice the prefix sum at index I. This will effectively measure how balanced the array is around that index. So we can say let delta equal ABS, which will get us the absolute value, total minus 2 times prefix sum square bracket I. Boom. And if the difference is exactly 0, that means both sides of the partition are equal, and in that case, there are 2 valid selections possible. So we could come underneath this, we could say count plus equals delta equals 0. So what this is going to do is it's going to return a Boolean. So if delta is equal to 0, we'll say plus equals 2, or else we could say colon and it'll be plus equals 0. Then if the difference is exactly 1, it means the two sides differ by just 1, and in that case, there's 1 valid selection. So in this case, we're going to come underneath this, and we are going to say count plus equals delta. This time, we're going to see if it's equal to 1. So if this holds true, then we are going to say, we're going to just say 1, or we can say colon, or it's just going to be 0, right? So we can either increment by 1 if this holds true, or we can increment by 0. Boom. And then finally, last but not least, we still need to return the total number of valid selections found by coming right here, and we can say return count. Now that's all she wrote, y'all. So let's give it a run before we submit it. Make sure it runs properly. Okay, let's see. Cannot find prefix. Oh, let me get rid of this S and let's run it again. Hopefully that did the trick it should. Okay, now what is it saying? It says, okay, so we have another typo. So I should just remove this I right here. And let's run it again. See if that did a trick. So let's see it's accepted. So now let's make sure it's still accepted after we submit it, because we all know how LeetCode can be. And look at that, y'all. 6 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.